What's up, Algebra 2? This is lesson 20. Our objective is how do you simplify radicals and what relationships do parallel lines have. So let's talk about simplifying radicals first. And in order to do that, we need to just understand this product of square roots theorem. It says that if I have the square root of a number times the square root of a number, it's equal to the square root of the product of that number. Or if you have the square root of a product, you can separate those and say the square root of the first one times the square root of the second one. So what that might look like is the square root of 3 times the square root of 4 would equal to the square root of 12, right? Because 3 times 4 is 12. And vice versa, if you have the square root of 12, that would equal the square root of 3 times the square root of 4. Okay? So let's just see if we can work with these to simplify this using that theorem. So the first thing we want to do when we're trying to simplify these, since these are different terms, notice it's separated by a plus or minus sign, I can only combine those if they have what we call like radicals, meaning if their square roots are exactly the same. And right now they're not. So what we're going to look at this 50 right here. We want to see if there's any perfect squares that are factors of 50. So just look at 50. Factors of 50 is 1 and 50. 2 and 25, 3, nope, 4, nope, 5 and 10. And there might be others, but we'll just stop there because I'm noticing right here is a set that contains a large perfect square. So I'm going to rewrite this first term here as 3, that's that 3 from right up there, times the square root of 25 times 2. Well, this would be the same thing as 3 times the square root of 25 times the square root of 2, using this property right up here. And the square root of 25 is 5, so it's going to be 3 times 5 times the square root of 2. And of course 3 times 5 is 15, so it's 15 square roots of 2. Minus, now let's see if we can do the same thing with the second one. So we'll look at this 200. Well, I know 1 and 200, 2 and 100, I can stop right there because 100 is a very big perfect square. I don't think I'm going to get a bigger one than that. So this is going to be the 5, this is that 5 right there, times the square root of 100 times 2, and I tried the perfect square first. It's going to be 5 times the square root of 100 times the square root of 2. The square root of 100 is 10, so this is going to be 5 times 10 times the square root of 2. 5 times 10, of course, is just 50. So it's 50 square roots of 2. And now, notice, this is the square root of 2, and that's the square root of 2, so I can actually combine these. So I have 15 square roots of 2, and I take away 50 of them. It's going to be a negative 35 square roots of 2. Okay. Now, let's look at example 20.2. It says 3 square roots of 2 times 4 square roots of 12 times 2 square roots of 3. So, I guess remember real quick, 2 times 3 is the same thing as 3 times 2. And also remember, the 3 times the square root of 2 is just really saying 3 times the square root of 2. So, kind of based on this, I can rearrange my radicals that I have down there. So notice this first one here is in blue. So I'm going to say 3. The second one's in red, so I'm going to say times 4. The third one's in black, so I'm going to say times 2. Times square root of 2 times the square root of 12 times the square root of 3. So just real quick, this 3 I put here, this 4 I put here, this 2 I put here. Here's the square root of 2, here's the square root of 12, here's the square root of 3. So all these numbers are in here. I just rearranged the order. And we know it'll be the same because what we talked about earlier. So let's just kind of combine these pieces together. This would be 12 times 2, which would be 24. And then this piece over here would be the square root of 2 times 12 times 3. Which is going to be 24 times... Well, I'm realizing this would be 2 times 36. I could multiply that to get 72, but hey, remember when we want to try to simplify this down just a second. And 36 is a perfect square, so I'll just leave it like that. So this is going to be 24 times the square root of 36 times the square root of 2. The square root of 6 is 6. Is going to be 24 times 6 times the square root of 2. It's going to be 142 square roots of 2. Let's do one more. This just involves some distributive property here. So I'm going to take this piece right here and multiply it in there. So I'm going to have 4 times 2, which is 8. And then I'm going to have the square root of 3 times the square root of 3. One from out here and one from right there. Minus 4 square roots of 3 times the square root of 16. Not 16, but 6. Okay, well this is going to be 8 times the square root of 3 times 3. Minus 4 times the square root of 3 times 6. 8 times the square root of 9 minus 4 times the square root. This is 3 times 6. 18. Well, 9 happens to be a full perfect square. This is going to be 8 times 3 minus 4 times factors of 18 would be 1 and 18, 2 and 9. Hey, look, that's a big one right there. So it's going to be 9 times 2. Square root of 9 is 3. Be 24. And 4 times 3 is going to be 24 minus 12 square roots of 2. And I cannot combine these terms because this one doesn't have any square roots and that one does. I could if I wanted to find a decimal approximation of that, but I don't want a decimal approximation, I want the exact answer. So there we go. And that gets you your basic idea there of simplifying radicals. Feel free to watch that part again if you need to. So let's talk about parallel lines. Parallel lines have the same slope but different y-intercept. So all three of these equations here are parallel because they have the same slope of 3, but all their y-intercepts are different. So kind of think about what that would look like on the coordinate grid. This one here in blue would pass through up 2, go up 3 over 1, so something like that. Same thing would pass through for this one. And it would pass up 3 here at 7, but the same thing up 3 over 1. So it looks parallel, even though my lines that I drew don't really look parallel. But you get the basic idea. This black one would be down here at negative 4, still going up 3 over 1, so something like that. Again, all three of those would be parallel. So let's kind of take that principle and apply it to being able to find equation lines. Example 20.4 and practice C are very similar. So let's see if we can move through these fairly quickly. It says find the equation of a line parallel to this equation and passes through the point blah 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 blah. So the first thing we want to do is we want to use this equation right here to find the slope of a line. The easiest way to do that is to get y is equal to mx plus b. And then we can look at that what number is right there in front of the x, and then we'll be able to find the slope. But it has to be in that form in order to be able to do that. So I have 2y, I'm going to add x to both sides, is equal to x plus 2. Then divide both sides by 2 to make this 1. So I have y is equal to 1/2 x plus 1. Kind of just a thought here, I said x over 2 plus 2 over 2. Well, 2 over 2 is just 1, that's where this 1 right here came from. And x over 2 is the same thing as saying 1 times x over 2, which is the same thing as saying 1 over 2 times x over 1, which is the same thing as 1/2 x. Really the important thing is that the slope of all this is 1/2. So now I have a slope. Since I want mine to be parallel, I have to pick the same slope. So my slope should be 1/2. And I happen to have a point. So if I remember my point slope form, if you don't, it's right here. Let's just plug it in. Y minus y1, which is -1, so is equal to m, which is 1/2, times x minus x1. It's going to be y plus 1 is equal to, distribute this in, 1/2 x minus 3 over 2. Subtract 1. Y is equal to 1/2 x 3 over 2 minus 1, or minus 2 over 2, because that's 1, would be -5 over 2. Same sign, so we add them. So that's the equation of a line that's parallel to this one and goes through that point. Okay, so same thing, find the equation of a line that is parallel, that's what that symbol means, to this and through that point. So let's work with this equation right here. 3y, I'm going to add x to both sides, is equal to x plus 5. Divide by 3. So y is equal to 1/3 x plus 5 over 3. The main thing I'm looking for is that 1/3. M is equal to 1/3. And I have a point right here, 3, 3. So to find the equation, I'm going to say y minus 3 is equal to 1/3 x minus 3. Send that in, y minus 3 is equal to 1/3 x. 1/3 times -3 is just minus 1. Add 3. Y is equal to 1/3 x plus 2. Alright, hope you understood that. If not, feel free to watch it again or ask questions. Good luck.